Okay, we're going to go through an example of simplifying and multiplying rational expressions. Now, the good news is if you've already factored polynomials, then you're really only taking one step further with this. So I'm going to go down. You'll notice I have some examples here. I'm going to do number 20. So if you have this for homework, you're more welcome to do this example right along with me. All right, so you'll notice we have two polynomials here. We have x squared minus 2x minus 3, and that's being divided by x squared minus 7x plus 12. All right, so here's the steps you want to take. Now, first of all, you can't just arbitrarily start canceling things out here. Some people would want to do that. They'd say, oh, x squared, cancel that out. Oh, we'll simplify this to 4. But you want to remember, you only can do that if it's involving multiplication. And right now, you just have addition and subtraction problems on the top and the bottom. So you can't just cancel out. However, here's what you can do. You can factor this. So what we're going to do is we're going to factor this out one polynomial at a time. We're going to start with the first one here. All right, so I'm going to factor that out off to the side. And hopefully you've had some practice doing this. If not, maybe this will ring a bell. Now what you want to do, this is a quadratic, so I'm going to identify A, which I don't have anything, so I can put 1. I want to identify C, which is negative 3. And B here is negative 2. Now A times C, that's what I'm really concerned with, which is 1 times negative 3, gives me negative 3. Now my goal is I want to find two factors, or two numbers that multiply to equal negative 3, but when I add those two numbers, I'm going to get an answer of negative 2. And when I do that, I can figure out that the two numbers I can use here are negative 3 and positive 1. When I multiply them, I get negative 3. When I add them, I get negative 2. So I like to factor using the box method. I know some people like to use different methods. I like this one. It's good to help you factor. It's a nice little visual. So then what I do is I just rewrite my problem. Now instead of the negative 2x, I'm going to break it up into pieces. I'm going to make it negative 3x and positive 1x. And I get my negative 3 here. And now what do? I just factor. I'm going to factor horizontally as well as vertically. So we'll go across here. X squared and negative 3x, common factor is x. 1x minus 3, the only common factor I can find is positive 1. X squared and 1x, again, positive, x, that's common factor. Negative 3 and negative 3x, common factor is negative 3. So I can factor that polynomial now as x minus 3 and x plus 1. So I can rewrite my problem now. So I haven't really changed anything. I've just rewritten x squared minus 2x minus 3 in a different way. I've written it as two binomials. All right, I didn't want to do that. Whoops. Let's shrink this down. Now my next step, I got to factor the bottom one now. So I'll do this in red. So I want to factor this polynomial. Now my goal is when I factor that, I should be getting one of the same binomials in the bottom. We'll see if that happens. If not, it's not the end of the world. So x squared minus 7x plus 12. So again, I can do A times C. 1 times 12 here gives me positive 12. Now, I want two factors of positive 12 that when I add them, I'm going to get negative 7. And I realize if I do negative 3 times negative 4, guess what? I get positive 12, and if I add them, I get negative 7. So those are my two factors. So now, again, I like to use the box method. Some people don't. I like to do this. It helps me keep track of my thoughts. So then I go with x squared. Now I'm going to go with negative 3x, negative 4x, and then positive 12. And then I just factor going horizontally and then vertically. So if I do x squared and negative 3x, common factor, x. Negative 4x and positive 12, common factor, negative 4. I'm going to go the other way now. X squared, negative 4x, common factor of x. Negative 3x and positive 12, common factor of negative 3. So now I can rewrite that down below as x minus 3, x minus 4. And I still have my binomial from before, x minus 3, x plus 1. And this is our goal. You want to see if they have something in common. They do. Both on the top and on the bottom, I have x minus 3. So guess what? X minus 3 divided by x minus 3. That gives me 1, and I don't even necessarily need to write that. They cancel out. So now my final answer would simplify to x plus 1 over x minus 4. Why do we do this? Because now it makes it a lot easier to solve for x eventually when we have to do that. Now this is an expression, so we can't necessarily solve for it. But I do know one thing. I know x can't equal 4 because 4 minus 4 gives me 0. And you know you can't divide a number by 0, so 4 is not a possibility. So I'm one step closer to figuring out what numbers I could use for x. And that's why you ultimately do this. You want to simplify. So that is how you would simplify this rational expression. Hopefully this helps you in the course of doing problems like this.